Hello, welcome to our video today where we're going to rename some fractions. And when we're renaming fractions, one of the things that I think a lot of folks have trouble with is that when we're renaming fractions, we're simply finding fractions that are equivalent to each other, but that might have a different name. Okay? So they mean the same thing, they just have a different name. We just call them something different. Before we talk about actually renaming the fractions, I do want to discuss fractions, right? Fractions are made up of a numerator, a denominator, and a fraction bar. That fraction bar separates the numerator from the denominator, but that's not all it does. That fraction bar has a special role in math. That fraction bar means division. Okay, it means to divide. Now, when we're dividing something, just a regular division problem, we're breaking something up into equal size groups. That's the same with the fraction bar. And that's sometimes what folks may not understand. When we're talking about fractions, those fractions have to be the same size part. Okay? They have to be because of that fraction bar, meaning division. And division meaning we're breaking something into equal groups. So for instance, let's say you're kind of hungry and you pop a frozen pizza in the oven. When it comes out, you cut off a little slice for yourself, right? You're going to take just a little piece right here. But then your brother and his friend smell that pizza, and they're older than you and bigger than you, and they eat more pizza. So you have to cut 2 more pieces for them. If you take this one piece, you cannot say that you have 1/4 of the pizza. You don't. You have 1 part out of 4 parts, but you don't have 1/4 of the pizza. We can't write that as a fraction because those parts are not the same size. So let's pop another pizza in the oven, and when it comes out, let's now break that pizza into 4 equal pieces. Once this pizza is broken into 4 equal pieces and we shade that 1 part, we can now say we have 1/4 of that pizza. Because of this fraction bar, meaning division, and division means that we break something into equal size groups. Now, when you did that, you went to go take your piece and you're like, this piece is way too big. I don't need that much of the pizza. So let me go ahead and take the knife and cut all of those 4 pieces that I just cut. I'm going to cut those all in half because I only want a piece about this size, right? But what did we do? We took the original 4 pieces that we cut our pizza into, and now we have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 equal size pieces in my whole pizza. How many parts are shaded? 1, 2. 2 parts are shaded. Because what I did was I doubled. When I cut this piece in half, I took it from 1 piece to 2 pieces. I doubled the number of parts, and I also doubled the number of whole pieces in my entire pizza. And guess what I just did? I just simply renamed a fraction. I went from 1/4 to 2/8. Do you see that I didn't shade any more or any less? It's still the same thing. It's the same size part. It's just got a different name. We went from 1 piece that was bigger to 2 pieces that were a little smaller, but together they're the same thing. Now, let's look at these rectangles. I want to go through a couple more examples really quickly with you. Now, each of these rectangles, you could probably see, have 1 part shaded, and there's 2 pieces in each of the whole rectangles, right? So I've shaded 1/2 of all my things. I have 1 part out of 2 pieces, and those 2 pieces are the same. I have 1 out of 2 that are shaded, I have 1 out of 2 that are shaded, and I have 1 out of 2 that are shaded. Each of these rectangles I shaded 1/2 of the whole thing. Okay, now for this guy, I'm going to do the same exact thing that I did for the pizza. I'm going to break my shaded part into 2 pieces. I'm going to double the number of shaded parts that I have. But because of this fraction bar that means division, these are not equal sized pieces anymore, which means I have to also draw a line down the unshaded part, and I went from 2 whole pieces, and right here I have 1 piece and 2 pieces that are the same size. Now I went to 1, 2, 3, 4 pieces that are the same size. I doubled the number of parts that my whole thing was broken into. And I just renamed 1/2 to 2/4 again. Okay, now this guy 1/2, instead of drawing 2 vertical lines, I'm going to draw 2 horizontal lines through the entire shape. When I did that, I took my original 1 shaded piece, and now I turned it into 1, 2, 3 shaded pieces, and they're all the same size thing. So I tripled the number of pieces that I shaded. What I also did was I took my 1, 2 pieces that made up my whole thing, and now I broke it into 1, 2, 3, 4, 5, 6. I also tripled the number of parts in my whole entire shape. So when I multiply my numerator and denominator by the same number, that's all I have to do to rename my fraction. How exciting is that? And I'm going to do it again. And some of you are going to say, wait a second, you just did that one. I want you to do a different one. I am going to do a different one. Not only am I going to draw 2 horizontal lines down the middle, I'm going to draw 2 vertical lines down the middle also. And now what did I do? I took my 1 whole piece and I broke it into 1, 2, 3, 4, 5, 6. I multiplied that 1 times 6. I now have 6 parts in my whole thing, and that means that I now multiplied my denominator, which was originally 2. I have 6 over here and 6 over here, so I have 2 sets of 6 in my denominator, or 12 total pieces in my whole thing. I just renamed 1/2 to 6/12. And now hold on to your hats. I'm going a lot crazy right here because I'm going to draw 2 horizontal lines. I'm going to draw 6 more vertical lines, and now what did I do? I renamed my fraction. But what did I rename it into? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 pieces on the shaded side. And then I'm going to continue counting to see how many pieces I have in the whole thing. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I have 24 pieces in my whole thing. When I multiplied my one thing into 12, I turned it into 12, I had to turn my unshaded piece into 12 too, which turned my whole thing into 24 pieces. I just renamed 1/2 into 12 24ths, okay? Now, when I'm renaming fractions, all I'm simply doing, I put a fraction bar in between each of these sets of numbers. The reason I did that is because I'm not really just doubling. I'm multiplying my 1/2 times 2 over 2. I'm multiplying my numerator times 2, and I'm multiplying my denominator times 2. Now, the reason that this thing works, some folks want to know the math behind it. It's because of something called the identity property of multiplication. And I'm just going to do a shortcut notation up there. The identity property of multiplication tells us that any number times 1 stays itself. So 7 times 1 is 1. 24 times 1 gives me 24. Absolutely. 37 times 1 stays 37. We could do this all day long. 196 times 1 is always going to get me back to 196. Now, the reason this property is important when we're renaming fractions is because right here, I put a fraction bar between these two 2's, which means that I'm taking 2, dividing by 2. What is 2 divided by 2? It's 1. So I'm multiplying this 1/2 times some form of 1 to get a fraction that's the same. That's why 1/2 is the same as 1, because the identity property of multiplication says 1/2 times 1 is still 1/2. 3 divided by 3 is 1. So when I'm multiplying 1/2 times 3/3, I'm really multiplying 1/2 times 1, and I'm getting a fraction that's equivalent to 1/2. What I like to show sometimes in my classroom is I like to show that I kind of draw a big, bold block letter 1 over the 6/6, because I'm multiplying 1/2 times 1 to get 1/2. It's just a different name. And same thing here, big block 1 over my 12/12. My 12/12 is equivalent to 1. It's like I'm saying 1/2 times 1, but it's giving me this 12/24, because the 1 is a form of 1 that's 12/12. So, the rule here, when we're renaming fractions, we have to remember, whatever we multiply our numerator by, we have to multiply our denominator by. We're just simply going to get a new name. We're not changing the shaded part, and the reason it works is because if we multiply the numerator times 7, let's say, and the denominator times 7, that means we're multiplying that fraction by 7/7 or 1, and the identity property of multiplication says that whatever that fraction is times 1 is still itself. I hope this helped, and I hope you come back to watch some more of these videos. They're as good as this one.